Start recording. Popping over back here. Your entire screen. There we go. Alrighty then. So today we are actually going to be starting a new Unity project, and this time we're going to be entering the realm of 3D. So what you're going to want to do is go over to your Unity hub, and in it make a new project. We are going to call this project Roll a Ball Game. And to make this project, you know the drill. You hit New, you hit 3D, and then the project name, we're going to name it in Camel Case. Camel Case is very specific. It just helps with files and finding things, but you do the first word lowercase and every other word uppercase. So we'll go with Roll a Ball Game. All right. Once you have that, hit create and it'll pull you up to your Unity window. All right. So as you're able to see, we are in a 3D Unity game. This is not 2D where we're dealing with only two dimensions. We have all of them to deal with here, and that might seem overwhelming at first, but if we really dive into it, it's not much more complicated. So, to start off, we're going to make a very simple game. Over the course of this lesson, over the course of this project, we are going to be making a rollerball game where we have a ball that you as the player can move. You're going to be able to collect collectibles, avoid hazards, and then you yourself are going to kind of branch off and explore and find something special to add to your game, build it, and be able to share it with people. So, with that being said, let's begin setting up our scene. This is where we're going to want to start, and this is where we're going to want to make sure we have everything ready for our code so that we're not dancing back and forth between windows. So, to begin, we're going to make something called a plane. Now, a plane is a 3D object that is simply a flat 2D space. The best way to show you is the best way to explain is to show you. So to make this plane, we're going to go to our hierarchy window or our scene window if you're using an older version of Unity. But we're going to go to our hierarchy window. We're going to right click. We're going to go to 3D object right here. Again, we're going to right click our hierarchy window, go to 3D object, and then you'll see you have options like cube, sphere, capsule, cylinder, and then there's plane right here. And you're going to click plane. Now by default, it's going to be at position 0, 0, 0. All right, and you'll see that we have a flat square. You'll also notice that you can only see it from one side. And that's actually relevant. The plane will only register from one side of itself. Uh, you'll notice this is a trick used when people do like platformers sometimes. Anyway, once we have our plane, we are now going to add our ball, right? This is going to be the object that we, as the players, are going to be able to move around on this plane. So, in order to make the ball, we're going to do the same thing. We're going to go in here, go to 3D objects, and then click sphere. Once the sphere is made, as long as we have it selected, we're going to hit the W key and then position the sphere to be somewhere above the plane. I like to use the shadow as reference to see how high I'm above, but also if you hit Alt and then you left click with your mouse, you can drag around, move yourself around the scene. So right here, I can see I'm about that high off the plane, and that looks really nice. So I want you to get your scene looking like that. Alrighty then. So, now that you have your ball here and you have your plane here, there's some little bit of groundwork we need to lay. We need to make sure that our scene is going to have all the components we need to interact with our code. So, since we already have our ball selected, what we're going to try to do is go into our inspector window here, and you see where it says sphere. We're going to click that, and we're going to name this player object. Again, in camel case. So lowercase for the first word, uppercase for the second word. And then hit enter to make sure it saves. And now our ball is named player object. Every other component it has in here is fine, but what we're going to do is we're going to add a new component by scrolling all the way to the bottom of our inspector, hitting add component, and we're going to be looking for a rigid body. To find a rigid body, we're going to use the search bar that is in our add component button. So again, you go to the bottom of your inspector and you click add component, and then use the search bar up top and start typing in RI. And as soon as you have RI, it should pop up as the first option. Now you'll see there's two different types of rigid bodies. There's a rigid body and there's a rigid body 2D. Now a rigid body 2D is for when you're making a 2D game and using their 2D physics engine. But we are making a 3D game, so you want to make sure that you select rigid body. Awesome. So, now you will realize inside rigid body there's a lot of different things that we can edit. We can mess with the mass, the drag, the gravity, even. After the lesson today, I encourage you to mess around with the rigid body and see what effects you can get out of it by changing them around on your object. And if you go too crazy and everything stops working, you can always just remove your rigid body by going to these three dots on the left and hitting remove component, and then just add a new one. And it will come in with all the default values. Anyway, so now we have our player object that has a rigid body and all its default transform meshes and colliders. What we need to do now is go to our plane, and all we're going to do on our plane is change the name to ground. Now we're doing this so that we as the developers can make sure we're keeping track of exactly what everything is. You might have 30 different spheres in your game world, right? You want to make sure you know which sphere is the sphere you're trying to select. So, once we have all that, we're going to then start moving into where we're going to code. Now, when we code, we're going to stay organized. And as you'll see in my... All right. So, we are going to move them to our assets folder within our projects area. And you'll see for yours, you should have just scenes. We're going to make a new one called scripts. To do that, we're going to right click. We're going to go up to create. And then you'll see you have all these different options. And you're going to click folder and name that folder scripts. Once you have scripts in here next to your scenes, you're going to open up scripts. And then again, you're going to right click, go to create, and you're going to make a C# script. That script you're going to name player controller, staying in line with our camel case of a lowercase player, uppercase C controller. All right. So now that we have our player controller made and ready to go, we're going to jump into coding. So let's open our player controller in Visual Studios. yours should take a second to load in. All right. So, once your Visual Studios loads in, we're going to write the code that you see before you here, but I'm actually going to delete mine and write it alongside you. Okay? Awesome. So, let me get rid of all this first. Now, as we go through the code and I start explaining little bits, if at any point you fall behind or think you need a little bit of extra information, in the activity guide, I actually have all of the code listed, and you can find that in the classroom. So, my screen should look just like yours, where you have your player controller open. In it is just player controller mono behavior and two functions, start and update. Let's spend a second to talk about start and update. Start is a function that runs at the very beginning of your scene. Whenever your scene loads up, this is the first thing run, and it's only ran once. So if you need a process done in the very beginning of your game, you're going to want this done in start. Update is very different. It not only runs in the beginning, but it runs every frame thereafter. In fact, update runs after start, and we know this because of the pattern that coding already follows, whereas it goes top down. If we have something written up here, it's going to run first before something written down here, so long as it isn't called in a function above. So just remember, start is going to be called just before update, and it's only going to be run once, at the very beginning of your game. And then update is going to run every frame thereafter. Now that we understand those, let's jump into the variables that we're going to use for our player controller. Going up here, above void start, but underneath of our mono behavior, we're going to make the only two variables we need for this code. We need one public variable and one private variable. The first public variable we're going to need is a float, so a decimal number that is player speed. And remember to keep up with your camel case when we write out something like this, so lowercase player, uppercase speed. Secondly, we're going to make a private variable, and this private variable is actually a rigid body. And we're going to name this RB. All right. Now, why do we need these two things? Well, in the inspector window, we're going to want to be able to edit the value of our variable for speed, because we might want to switch that around, play with it, change it in that window. We are grabbing our rigid body because that is the thing we're going to manipulate in order to move our object around in this 3D world. But we don't have our rigid body assigned yet, and it's a private variable. So we're going to have to do something a little bit more complicated in order to assign our rigid body. To do that, we're going to go inside of our start here on my line 14. In our start, we're going to make sure that we format correctly and we tab in. And then we're going to write RB equals. Now, we can't just write RB equals rigid body. That's not going to work. We need the very specific rigid body that is attached to the same game object that this script is. We can reference the same game object that this script is attached to by doing lowercase g game object. Make sure that your O is capitalized. Visual Studio should be trying to write these out for you. Let it. It'll vastly speed up your code. It'll make your life easier the more you get used to letting some of the software do the work for you. So now that we have RB equals game object, we still have some more work to do, right? Because RB is a rigid body and our game object is a game object with various different components. So we're going to have to single out that component. We can do that by using a function that's pre-built into here called getComponent. You'll see I'm going to select this third one down. Now, once you write getComponent, you actually need to do brackets with the carets, so the less than symbol and the greater than symbol. Inside of those brackets, we're going to type in rigid body. And then after those, we're going to add parentheses because this is a function. And then we can cap that line off with a semicolon. Now, this is different than just saying RB equals rigid body because we're being very specific in saying that RB equals the rigid body that is attached to this game object and no other rigid body. We have to keep in mind that when we talk to our computers, we need to make sure that we are extremely specific. Because if you were vague, you could grab the wrong thing, or better yet, it just won't know what to do and cause an error. So now that we have RB set up, we can get working on how we're going to get our ball to move. So I'm going to quickly save to keep up the habit, and I do that by hitting Control S. And then I'm going to move into the update function. Now, on my line 20, in the update function, we're going to start with an if statement. Now, an if statement is very important. You're going to use this a lot as you code. And it's very useful, consequently. The if statement will always do what's in its curly brackets that you put underneath of it here, as long as what's in its parentheses up top is true. So to simplify that, an if statement has a condition, and if that condition is true, it's going to run what's in its parentheses. This might be something you already know, but I'm just covering it in case somebody doesn't. Now, what goes in our if statement is going to be a little bit more complicated because we're looking for some sort of feedback from the player, right? We don't want our ball moving by itself. This is a player controller. So we're actually going to use something called input. This is built into the Unity engine. Input looks for something, some sort of feedback from the hardware attached to the computer, and will help us return a true or false statement. But we need to add more to input in order to get that true or false statement. Now, the function built into input that we're going to use is called getKey. Now, there's a lot of versions of getKey. There is getKey up, getKey down. All they do is exactly what they say they do. GetKey up returns true if the key is not pressed. GetKey down returns true once if the key is pressed. And getKey, well, is the only one that's not very specific in what it does, but it's the one that we're going to use because what it does is it returns true so long as that key is pressed. So, in order to tell it what key to look for, we're going to have to write something in these parentheses here. Now, some of you might know that computer keys and referencing them can actually be kind of difficult sometimes. You can't just say the A key in most cases, but Unity has something built in called key code. Key code is designed to translate these for us so that we can use more simple terms in order to reference our keys. So, let's start off with keycode.up. And you'll see keycode up arrow, page up. We want up arrow. So this will return true anytime the up arrow on our keypad is pressed. Now when that returns true, what do we want it to do? Well, we want our ball to move forward. We can do this very simply because we singled out that rigid body. What we're going to do is we're going to write RB dot, or not dot, sorry, RB dot add force, and we're going to use this function here. Now, what add force does is it does exactly as it says. It adds a force to a rigid body. The rigid body, again, is attached to an object, and because all those things come into place, that object moves. So, in add force, we have to add something. We have to add a force. We're going to accomplish this by taking the player speed and multiplying that player speed by a vector 3, but we're doing it by a very specific vector 3. You're going to type in vector 3 dot forward, and you're going to save. Now, what are we referencing when we say vector 3 dot forward? What is a vector 3? Well, a vector 3 is essentially the transform of your object. It is a location somewhere in the grid, it is a direction, it's a series of numbers that references somewhere on our scene, right? In our scene. There's specific vector 3s that are pre-made that people use all the time, so they're made within Unity, they're hard programmed in there, and that would be forward, up, left, right, down, back, right? And those are the very smallest amount you need to register that direction. When we multiply that by player speed, we're then increasing that amount, and that allows add force to add a force in that direction, right? We're not really in this function making the amount of force. We're instead saying go here, and it's a little bit further away than normal. So then rigid body add force calculates what speed it needs to throw at the ball for it to reach that destination. That might not make total sense right now, but as you continue to program, it'll start to make more sense. So anyway, we're going to save real quick, and we're going to jump back to our Unity scene. And we're going to jump here just to give it a test. So we're going to take our player controller and add it to our player object. We're going to do this by clicking on our player object in the hierarchy, scrolling down in the inspector. Again, we're going to click it in the hierarchy and scroll down in the inspector and go to add component. And then we can search it by the name that we have it called there. So we're going to go player, and you'll see player controller. But hey, you'll notice something's a little different. The P is capital and there's a space in there, right? That's the reason we use camel case, because Unity will interpret that as add a capital and add a space. It's a formatting thing because you can't add a space to your scripts or else it'll cause them to bug out and they won't work. But this is the alternative so that it looks nice in your inspector window. Anyway, now that we've found player controller, we're going to click that and add that to our player object. All we need to do is set the speed. I'm going to go with 3, save real quick, and then hit play. Now, not only does our ball fall because it has gravity, but if I hit the up arrow, we'll notice it moves away from me, until eventually it falls off of our plane. Quickly, before we jump back into our code, let's make our plane a little bit bigger, so that we can play around with it more once we get more directions going. I'm going to do this by going to the transform of our ground and finding scale right here. And in scale, I'm going to take the x variable and make it 10. And then I'm going to skip over the y variable and go to the z variable and make it 10. Now the reason we're not editing the y variable is because a plane has no y. It's only an x and a z. The plane can't go up, right? You can rotate the plane but at the end of the day, it's only a flat distance between four different points. If it went up at all, it would be a cube, and we would make a cube in that respect. Anyway, now that our plane is a little bit bigger, and we can see that by hitting run again, and now the ball can move until it's just a little tiny dot or it falls off. But now let's make it a little bit more interesting. Let's add some pizzazz and let our ball move in the other directions. So we're going to move back into our script. So let's take this here and actually turn it into a function because we want to stay organized, and if we're doing this for every direction, it's going to become a lot of code, and we want to make sure that we're not crowding our update with a lot of code. We want to always be able to reference a point of our code, and that's why we make functions. So underneath of update, we're going to write void movement, like this, right? And now we can call movement whenever we want something to run this code within here, right? We're actually going to take what we have in update. We're going to cut it by hitting Control X, and we're going to put that in our void movement. Now you'll notice I also added movement with some parentheses up here, and then a semicolon. What this is doing is it's referencing the function we are currently making. And that function is going to run every update cycle. It's the same thing, but it's a little bit more organized, a little bit easier for us as human beings to keep track of. Now, I just talked about us as human beings, but now we're going to talk about us as coders, right? Because coders are inherently lazy. And this is a good thing, because you're going to find that if you're doing this correctly, you're slowly going to find the easiest ways to accomplish problems. And the easiest ways to accomplish problems in coding are oftentimes the best ways. Now, the easiest way for us to write out every single direction would be to take our if statement and copy it, and then paste it below. And now that we know we've moved up, let's do down. And then instead of moving forward, we'll move back. And we're going to do this again for left and right. So I'm going to do that here and give you guys a minute to do that on your own time. And then we'll keep going. Some things to watch out for. Make sure that after your vector free 3, that variable that you call that pre-assigned variable that you call, whether that's forward, back, right, or left, make sure that it starts with a lowercase variable. Right? These are case sensitive, and the uppercase just doesn't exist. Make sure your vector 3 is uppercase at the beginning, the lowercase is something different. Make sure your player's speed matches your player's speed up at the top. And make sure that your key codes are for the arrows and not for another key. Sometimes people mess that up on their first go. Anyway, once we have all of this, we'll save. and we'll move back over to our Unity. It'll take a second to load in, and then we hit play. Now you should find that you can move your ball in any direction that you choose. You have full control over it. In fact, you can go as far as to increase the player speed. So I'm going to go from 3 to 5 just to demonstrate that because we set that to a public variable, now we have a little bit more wiggle room with how we can go about editing our code, because we can do that from inside the inspector. All right. So let's make sure we save our project. Hit Control S in here. And for class today, that's what we're going to cover. If you have any questions, please ask them in the chat right now, and I'll answer them before we wrap things up.
What do you mean by that? Why it's not letting you do it?
You saw what Major just wrote?
I'm about to check it.
Mm.
I need help. My ground is a rectangle shape. Okay, so I think I understand what you're talking about. Let me jump over to my scene, and I will show you how to put in the plane again so that we get it all working right. Sound good? So I'm going to just select my ground and delete it. If we're having an issue with it, we're better off starting over because maybe you missed something, and that's okay. We're all human. So I need to put in a ground. I need to put in a plane. Starting back to where we were when we did this, we go to our hierarchy window and we right click. Then we make our way to 3D object and we click on plane. Now your plane should spawn in at 0, 0, 0, and it should look just as it is here. What we're going to do to plane is we're going to go to the name, we're going to change it to ground, and then to make it larger, we're going to go to scale here, right here. We're going to go to the X value, we're going to make this 10, and then we're going to go to the Z value, not the Y, but the Z value, and also make this 10. Now the reason we do not edit the Y is because this is a plane and it's not a cube. If it had any sort of vertical dimensions to it, then this would be a cube and we wouldn't be working with a plane. A plane is simply just a flat space in a 3D world. Once you have that, go ahead and save it. It should already have its mesh collider on, and that should work. Once you have that, ping the chat. Let me know if you got that. Sweet. All right. And with that, you should have your movable ball. Now, between classes, what I'm going to encourage you to do is try and find a way to make this ball jump. Right? That is your challenge between classes, as a little bit of a bonus. I would also very much recommend checking out the inspector window and messing with the rigid body and seeing what different effects you can get. Or maybe even adding another object to your scene so that you can see how collision will affect your object. anything you do, or even your project now, feel free to take a screenshot and post it in our stream so people can see what you're doing. All right? Next class, we're going to deal with colliders and hazards, I believe. So we're going to get to have fun with tags and things like that. All right? Glad to have you guys for today, and I look forward to seeing you next class. Bye now.